Hey there, fellow knowledge seekers. Beast Gamer here, and today we're diving headfirst into the wonderful world of circles. Get ready to unlock the secrets of these perfectly round shapes that are everywhere around us. So buckle up, hit that subscribe button, and let's get this circle party started. Alright, let's start with the fundamentals, shall we? Imagine a single point in space. Now, picture all the possible points that are the exact same distance away from that center point. What do you get? That's right, a circle. It's like a never-ending loop of points, all joined together in perfect harmony. And that distance I mentioned, the one that connects every single point on the circle to the center, that, my friends, is called the radius. Think of it this way: every point on the circle is holding onto a string, and that string leads right back to the center. No matter where you start on a circle, you can always trace your finger along its edge and eventually end up right back where you began. Now that we've got the basic idea of a circle down, let's dive into some essential circle vocabulary. We've already met the radius, but it's got some friends we need to get acquainted with. First up, we have the diameter, which is like the big brother of the radius. It's a straight line that goes right through the center of the circle, connecting 2 points on the circle's edge. Basically, it's just two radii holding hands. Next, we've got the circumference, which is the total distance around the circle's edge. Think of it like the circle's waistline. Now let's talk about chords. A chord is any straight line that connects 2 points on the circle's edge. Alright, let's talk about what makes circles so special. Circles have some pretty awesome properties that make them stand out in the world of shapes. First and foremost, all radii of a circle are equal. This is what gives the circle its perfectly round shape. Next up, the diameter is the longest chord in a circle. It's the king of all chords, cutting the circle perfectly in half. And because it passes through the center, it's the longest straight line you can draw within the circle. Circles are also symmetrical, which means you can fold them in half along any diameter, and the two halves will match up perfectly. Now it's time to equip ourselves with the formulas we need to conquer any circle-related challenge. First up, we have the circumference formula C equals 2 pi r, where C is the circumference, pi is a mathematical constant approximately equal to 3.14, and r is the radius. This formula tells us that the circumference of a circle is always a little more than 3 times the length of its diameter. Next, we have the area formula A equals pi r squared, where A is the area and r is the radius. This formula tells us how much space the circle occupies. We can also calculate the length of an arc using the formula. Arc length equals theta divided by 360 degrees times 2 pi, where theta represents the central angle of the arc in degrees. And finally, we can calculate the area of a sector using the formula sector area equals theta divided by 360 degrees times pi squared. Circles aren't just confined to math textbooks. They're all around us. Think about it. Wheels, clocks, coins, buttons, even the pupil of your eye. Wheels are a great example of how circles help us move things more easily. The circular shape allows the wheel to roll smoothly over surfaces, and the axle at the center keeps it stable. Clocks use circles to represent time, with the hands moving around the circular face. Coins are circular for a few reasons. The shape makes them durable and easy to stack, and it also prevents them from having sharp corners that could poke or tear things. Sports fields often incorporate circles as well. Get ready to unleash your inner architect because we're about to delve into the world of geometric constructions with circles. One of the coolest things you can do with a compass and a straight edge is construct a perfect circle. It's like magic, but with math. You can also use these tools to draw a tangent to a circle from an external point. A tangent is a line that just grazes the circle, touching it at exactly 1 point. Inscribed circles and circumscribed circles are a whole lot of fun too. An inscribed circle fits perfectly inside another shape, like a triangle or a square, touching each side at exactly 1 point. Get ready for some mind-blowing circle trivia. Did you know that the value of pi is irrational? Meaning it goes on forever without repeating? That's right, the digits after the decimal point just keep going and going. It's like the circle's way of saying, I'm infinite and mysterious. Speaking of infinite, circles are often used to represent infinity and eternity. They have no beginning and no end, just like the cycle of life, death, and rebirth. Circles are also found throughout nature. Think about the rings of a tree, the ripples in a pond, or the shape of the sun and the moon. All right, team. It's time to put our circle knowledge to the test. Let's say we have a circle with a radius of 5 centimeters. Our mission, should we choose to accept it, is to find the circle's circumference and area. First up, let's tackle the circumference. We can use our trusty formula C equals 2πr. Plugging in our radius, we get C equals 2 times pi times 5 centimeters. Simplifying that, we get C is approximately 31.4 centimeters. Now, let's calculate the area using the formula A equals PR squared. Plugging in our radius, we get A equals pi times 5 centimeters squared. For those of you who are feeling extra adventurous, let's venture into some more advanced circle concepts. First up, we have concentric circles. These are circles that share the same center but have different radii. Think of a bullseye or the ripples in a pond after you throw a stone. Next, we have seconds. A secant is a line that intersects a circle at 2 points. And finally, let's talk about cyclic quadrilaterals. A cyclic quadrilateral is a quadrilateral whose vertices all lie on a single circle. Congratulations on making it this far on our circle journey. You've learned a ton about these perfectly round shapes, and now it's time to solidify your knowledge and develop your circle-solving skills. First and foremost, understanding the formulas is key. Don't just memorize them, try to understand what they represent and how they work. Visualization is your best friend when it comes to geometry. Whenever you encounter a circle problem, try to draw a diagram to represent the situation. This will help you see the relationships between the different parts of the circle and make the problem easier to solve. And finally, practice, practice, practice. The more you work with circles, the more comfortable you'll become with the formulas, concepts, and problem-solving strategies. That's a wrap on our epic circle adventure. We covered everything from the basic definition of a circle to advanced concepts like concentric circles and cyclic quadrilaterals. Thanks for joining me, and I'll catch you in the next video.